The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. Thanks for joining today. My name is Andrew Shikiar. I lead marketing here at FIDO Alliance, and I'm joined today by Salah Machani of RSA. We typically open these webinars with some background slides on FIDO for the less initiated. But for this webinar, we're going to skip that portion and get right into the details with Salah. But briefly, for those of you who are not familiar with FIDO Alliance, we're a consortia of over 250 companies working to create open standards and an interoperable ecosystem for strong authentication. This includes creating specifications, certifying products for conformance and interoperability, and driving market and regulatory awareness through programs such as this webinar. To date, we've seen strong deployment of FIDO authentication on a global scale from companies such as Google, Facebook, Samsung, Bank of America, Entity Docomo, and many more who have collectively enabled FIDO for over 3.5 billion user accounts. Our members work together to achieve these goals and also to share best practices on the most effective way to tackle common challenges for FIDO deployments. On that note, today we'll hear from Salah Machani on how FIDO fits with Federation. This is actually a common question we get, as on the surface, many of FIDO's core principles may seem to conflict with Federation, but in reality, as you'll learn, FIDO can be highly complementary to federated identity deployments. Before we start, just a few housekeeping items. First of all, yes, this will be recorded, and the slides and replay will be shared with you afterwards. Secondly, in the GoToWebinar client, you'll see a question dialog box. You can ask type questions in there, and we will answer them in the Q&A session at the end. So I will read the questions out, and then either Salah or I will answer them at the end of the webinar. Other questions, we can try to answer midstream as the webinar goes on. You'll also see in the GoToWebinar client a handout. This is a enterprise adoption best practices for Federation document that will be partially covered in today's webinar. Last but not least, you'll see a survey at the end of the webinar. If you could take a few minutes to fill that out, we'd really appreciate it. Your feedback, it really helps inform our webinar program moving forward. So with that, I'm now very pleased to introduce Salah Machani. Salah is a Senior Director of Technology at RSA, and he's also a Board Director here at FIDO Alliance. Salah, over to you.
Thank you, Andrew. Thank you, everyone, for joining us today. I'll cover today three main questions around FIDO and Federation. First question is, what is FIDO and where does it fit in the security stack, and how does it actually differ or complement Federation protocols? Second, what are the benefits of combining FIDO with Federation? What's in it for an organization and for end users? And third, if you were to deploy FIDO today in a federated environment, what's the best way of doing that? And that's more or less what the paper covers. In my talk, I will focus more on the enterprise deployment scenarios. Some of the points I'll be making apply to other environments, but some don't. So keep that in mind as we go through the presentation. So what is FIDO? I'm assuming you have some background knowledge on FIDO, but I want to give you some perspective on how FIDO relates to other protocols in the security stack. The main task of FIDO protocol is to ensure that the user coming back to access an account is the same user that created and owns that account. It functions in a way that's convenient to the user and that's secure, using much more modern technologies, such as biometrics. So by this definition, FIDO is an authentication protocol. However, it does not issue authentication statements that can be used across multiple applications or across different security domains, the way Federation protocols work today. So FIDO differentiates from that perspective from Federation protocols. So it's not Federation protocol. It does not also issue authorization statements that stipulate what resources the user is allowed to access and what permissions on those resources the user has. So it's not an authorization protocol. Also, it does not provide or manage any user identity attributes. So it's not designed to solve the identity proofing problem. So very quick refresher on how FIDO works. At the architecture level, there are three main components to highlight. FIDO server that is typically hosted by a reliant party offering services to end users. FIDO client that's built into the platform of the end user device. This can be built into the web browser, it can be integrated in a mobile application, or it could be part of the operating environment, or a combination of those. And then there is the authenticator, which can be embedded and bound to user device, or it can be external and can move from one user device to another user device. The RP application runs on the top of these components to leverage FIDO-based authentication using very simple APIs. In the core of FIDO, there is a very simple public key-based crypto protocol. So how does it work at a very high level? At the registration time, the authenticator generates a public and private key. The private key is kept in the authenticator. It's protected using strong form of encryption, typically anchored in the hardware of the device. The public key is sent to the server for storage, and it can be bound to the user's account by the reliant party application. In some cases, the public key can be asserted using an authenticator provider attestation key that's embedded in that device. As you can see, there are no client certificates in this model, so there's no need for public key infrastructure. At the authentication time, the server generates a challenge and sends it down to the authenticator. The authenticator prompts the user to provide some form of a gesture, like biometrics, to unlock the private key. The authenticator then signs the challenge and returns the signature back to the server. The server verifies the signature using the stored public key, and then the application server grants the user access. So in this model, as you can see, there are no secrets stored on the server. If biometric is used, the data is not sent to the server, preserving user privacy. And obviously, there are some other details in the protocol, including some of the security measures that are built in to prevent replay attacks, phishing, man-in-the-middle attacks. I'm not going to address those today, but there's a lot of material on the FIDO Alliance website that you can have a look at. So now let's look at how FIDO credentials can be linked to user identity. In the first leg of the protocol, the user authenticates to an authenticator in order to unlock the private key. The authenticator recognizes the user as the same one who created the FIDO key in the first place, but it does not know the identity of that user, since it does not store any personally identifying attributes. If you look at the second leg of the protocol, the user can recognize the authenticator as the same one the user registered before, but it does not know the identity of that user, since it does not store any user attributes. So the FIDO protocol does not collect, store, or process any user identity information, and therefore it cannot link FIDO credential to a real identity. If it's needed, the RP application will have to collect user attributes and perform some form of identity proofing outside the FIDO protocol in order to establish that link or association between FIDO credential and the user's real identity. Another property of FIDO I want to highlight is the ability of an authenticator to generate unique authentication keys for different reliant party applications while keeping total isolation between authentication transactions across those RPs. So no one RP is aware actually of the existence of a FIDO credential for another RP in the same authenticator. In fact, certified FIDO authenticators cannot use the same FIDO credential across different origin servers that belong to different RPs or belong to different security domains. So what are the benefits of FIDO to the end user? Three key benefits I want to highlight. First, it reduces the burden of remembering multiple passwords for multiple applications. It does that by requiring simple gestures for authentication. The same gesture can be used across all applications. Second, it reduces the burden of using a variety of two-factor authentication methods if provided by the applications. In FIDO, the user is only allowed to use single authenticator for all applications, so they don't have to carry multiple authenticators. And third, it preserves user privacy. Users have no longer to worry about their secrets or their personal attributes being stored on RP servers. And they don't have to worry about businesses that they deal with having visibility on what applications or services they might be using elsewhere. So how does federation differ then from FIDO? Before federations, users had to remember multiple passwords for different applications. They had to sign in every time they switched from one application to another. Browser cookies were introduced to make authentication sessions last longer and provide better user experience, but they cannot be shared across web applications or across different web origins. This is actually one of the most important security policies in the web that's enforced in the browsers. Authenticators had also a lot of challenges without federation or before federation. They had to manage authentication policies across multiple domains as the number of SaaS applications employees start growing as well. And they had to manage group policies, group permissions, and user accounts across multiple of these domains. For example, if an employee leaves company, the administrator has to revoke their credentials within the home security domain and also across all the other external applications that they were once allowed to use. So the net result of these challenges are the increased level of security threats and risks, decreased level of employee productivity, increased administration overhead, and increased number of help desk calls primarily due to password resets. So how does federation solve this problem? Federation defines a model in which there is a three-party trust relationship. It consists of a user, an identity provider or an IDP, service provider, also called a relying party or an RP. The IDP acts as an authentication authority in this model. It authenticates the user and issues authentication statements in the form of assertions or tokens. The RP application then consumes the presented authentication statement. It verifies that it's coming from a trusted IDP, and then it grants access to its resources and services for the user. In enterprise deployments, the IDP is typically under the administration and management of the enterprise IT. It may reside on-premise or it may reside in the cloud. In either case, it will have access to user identity source where identity attributes are kept. The IDP can choose to share those attributes with specific RPs as permitted by the enterprise policy. So what does this mean to the end user? The user only needs to authenticate to the IDP, which means they only need to remember one password or use 1-2FA method if it's supported. They can sign into the IDP once, obtain a time-bound assertion or token, and present it to one or multiple different RP applications for access. So in a way, they avoid having to set up multiple passwords for different applications, and they don't have to sign in multiple times a day with different credentials every time they switch from one application to another. From the perspective of RPs, such as SaaS application providers, federation allows them to delegate user identity management and authentication to trusted third-party authentication authorities, which means eliminating the overhead and the liability of protecting user identities and user credentials. And from the perspective of an organization acting as an identity provider in this federation model, there are huge benefits. Security risks and the administration overhead will be significantly reduced since the authentication and authorization policies will be centralized. They can implement and enforce new authentication methods without depending on RPs. They can also enable single sign-on experience for their employees by issuing authentication statements for multiple domains. And they can protect user identity attributes and share them only when needed with their line parties. Many enterprises have deployed federation today, and they were actually successful in addressing some of these issues I just went through. But most importantly, they were able to enable single sign-on experience for their employees to increase productivity. So what is the downside of federation? If you look at the current implementation, they all rely more or less on password as the primary or as the first factor for authentication. Single sign-on experience is very effective. Users like browser reduction, but they hate updating passwords or remembering and entering complex passwords. At the same time, organizations have major concerns about the security of passwords. With the growing number of non-federated shadow IT applications that users access inside the company, and the number of personal applications they also use outside the company, the number of passwords they have to remember continues to grow. So it's very common for users to maintain the same password for corporate access and for personal accounts. That puts corporate accounts at risk. And that's the main reason why organizations who deploy Federation today are seeking more modern authentication methods that can improve the security of their Federation solution and can provide a better authentication user experience. And this is where FIDO comes into play and can complement Federation. It can offer that stronger security and superior user experience for Federation authentication. So FIDO is the solution for that. So in the preferred deployment option, I'm showing here in this slide, and I will cover afterwards a couple of other options. In this option, the FIDO server is deployed by the IDP. So the IDP is responsible for authenticating the user using FIDO methods. So deploying FIDO with Federation will offer a lot of benefits to the user. The user is only required to use one authenticator and just one credential. So they don't have to have multiple credentials for multiple applications. And the organization in this model can enforce FIDO authentication across all RP applications without requiring changes to the RP applications. So the RP applications can continue to use federated authentication without actually having to change the applications. And for the organization, there are a lot of other benefits they'll be gaining from this, combining these technologies. There will be lower security risks. So everything is centralized in their domain. There will be lower help desk calls, increased productivity since they can enable single sign-on using FIDO. And overall, they will have lower cost of ownership. In this diagram, I'm showing now how to integrate FIDO with Federation. This is very typical Federation authentication flow. It captures how most common Federation protocols work, namely SAML and OpenID Connect. The only thing that's really different than what you have implemented today, if you have Federation implemented, is in step 3, where the FIDO protocol is triggered, and the user is required to use FIDO authenticator as opposed to using a password or some other form of authentication. In steps 2 and 5 in the diagram, which is the authentication request and the authentication response, they may actually include some indications that FIDO authentication is required or that the user was authenticated using FIDO, but that's optional. So how do you apply FIDO-based authentication and support the flow I just showed you? There are 2 options you could consider for that. One is on the IDP side. The IDP can enforce through policy configuration that all requests coming from all RPs will go through FIDO-based authentication, or they can define different policies for different RPs. They could also consider using risk and contextual data to enforce FIDO-based authentication. And the second option is on the RP side. They can request from the IDP for authentication to be FIDO-based or to meet certain authentication assurance level that can be satisfied using FIDO. So those are the 2 options for enforcing FIDO-based authentication. And I'll show you an example here with SAML, how the second option can work, where the RP requests from the IDP that authentication is FIDO-based. There's an attribute in SAML, if you're familiar with SAML, called the Authent Context class reference. This attribute can be used actually to identify either an assurance level or policy or FIDO as a method for authentication, and then the IDP has to enforce that method. The IDP, after authenticating the user, can return information back to the RP in the same attribute, indicating which method was used to authenticate the user. So in this example, I'm showing the request indicates medium assurance level, and the IDP is returning back information to the RP suggesting that user was authenticated using FIDO and it met the medium assurance level. At this time, I have to mention actually that there's no dedicated URI registered for FIDO authentication as part of the Authent context class reference. So if you are a federated RP and you want to use this method, you will have to work with your IDP to agree on what URI to use as an identifier for FIDO authentication. The IDP actually could choose one of the registered URIs, so there are a number of them that are registered as part of some standard, or they could use custom URI to indicate FIDO as the authentication method. And this is an OpenID Connect example. Very similar. There is the ACR values request parameter in OIDC that's equivalent to the Authent context class reference in SAML. It can be used by the RP to indicate FIDO authentication. And there are two claims, the ACR claim and the AMR claim, that can be returned by the IDP in the ID token to indicate that FIDO authentication was used. ACR values are defined in the OpenID Connect standard specification, in the core specification. But there are two new ACR values in new draft. It's called the extended authentication profile ACR values you can look at. It defines two new values, the phishing resistant and phishing resistant hardware protected, PHR or PHRH. Those are the two values that actually we recommend to use for FIDO. They are proposed kind of to support FIDO. So if you are an RP, you still have to check with your IDP whether they support these values or not, and if they don't, which values to use. So now I'll give you kind of a quick look at a couple of other deployment options. I mentioned the first preferred deployment option where the IDP deploys the FIDO server. So in this deployment, the FIDO server is deployed by the RP instead of the IDP. So this situation you may run into as an RP when the IDP you're using for primary authentication does not support FIDO and you want to support higher authentication assurance level. So the IDP in this case continues to use non-FIDO-based method, and the IDP performs FIDO-based authentication as a secondary method or a step-up. Solution, in my view, is not very suitable for an organization that's trying to replace passwords and provide consistent multi-factor-based authentication experience across all applications. In order to do that, the IDP or the organization has to get all the RP applications to deploy FIDO in order to provide a consistent experience to the users. In this third option, both the IDP and the RP can deploy FIDO. This solution actually offers the highest federation assurance level. In fact, if you look at the latest NIST 863 publication, it does recommend this configuration to qualify for Federation Assurance Level 3. Obviously, there are other conditions that you have to meet in order to meet that level of assurance. But this is kind of one of the configurations you can use to meet the level. So in this case, what's happening here, the user has to register two FIDO keys on the same authenticator, one with the IDP and one for the RP. So the IDP authenticates the user first using the first key, using FIDO, and issues what's called the holder key assertion with a reference to the second key. So the assertion itself has kind of an index that points to the second key. And then the RP, when it receives the assertion, it verifies it and challenges the user to prove ownership of the second key using FIDO. So the user will end up going through FIDO authentication twice in this type of configuration. So to summarize, I want to highlight the most essential benefits for combined FIDO federation. With a combined solution, the user continues to enjoy the benefits of federated authentication, specifically single sign-on experience, but they will do it in much more convenient and more secure way. And organizations will be able to offer stronger and more convenient authentication method without putting user identity attributes at risk. And to close, I want to leave you with two recommendations. One is, if you are using Federation today, don't wait, plan to add FIDO support. There are more than 200 certified FIDO authenticators. and there are more than 85 FIDO-certified server implementations. In fact, some of those server implementations are part of Federated Authentication solutions, like the RSA Secure ID Access Assurance Service. And I think, like Andrew mentioned, there is a white paper that we published recently, and it's in the handouts. I recommend that you look at it. There are a lot of details there in terms of the integration between FIDO and federation protocols. And with that, I think we have time for some questions. I'll pass the ball to you, Andrew.
Yeah, we